Okay, my friends, so we've seen raw data, which is one way of presenting data to someone. It's actually my favorite way of getting data because then I can do whatever I need to do with it. It's also messy. It's a huge, as we saw, it's a huge list of numbers that is not exactly the most pleasant thing to look at. So a frequency distribution is often a good way of looking at it, but sometimes you just need more of a picture. You need more of a two-dimensional look. One of the ways to look at data like this is called a pie chart. Okay, so this is the first one we're going to look at, pie charts. This is what happened when I went into Microsoft Excel and I created a pie chart off of this data right here. Literally just selected all this data and inserted a pie chart. I'm going to pause right here for a second, actually, and I'm going to show you on our school's website, on the class website. If you go to my site, Sean Rule, and then you wander over to the resources page, which we don't usually go to the resources. We spend a lot of time in schedule, a little bit of time in Excel calculator, but resources occasionally I will point you to here. If you go to the resources page and you go to the Intro to Statistics topic, which we're in right now, there's 3 videos: how to create a pie chart in Excel 2010, how to create a bar chart, we'll get to that later, in Excel 2020, and how to create a line chart in Excel 2010. So you've already done scatter plots up here in correlation and data mining, and we've been using those kind of ever since then. But here's 3 more kind of how-to videos. Granted, it's Excel 2010. I think you are now up to at least 2016, if not further. But 2010 and 2016 look effectively similar. So if you need help creating these charts, I walk you through them here. All right, back to our frequency distribution. Here's our pie chart. So just selected the data and dropped in a pie chart. I'm not a fan of this. I'm not going to lie to you, for a number of reasons. First off, it's got way too many colors, which I'm not a fan of at all. I do not like the fact that they're color coded down here, and that's fine. And, you know, it goes 0 through 10, which is also fine. And if you know what you're looking at, which is the number of quizzes left to do in winter 2020, that might be fine. But honestly, making somebody have to figure out how big these pieces are with respect to each other, I think is annoying. So one thing, if you're going to make a pie chart, at least have the common courtesy to include data labels, whether it's the counts or whether it's the percentages. Whether it's the counts or whether it's the percentages. And I just noticed as I'm looking at this one, you see how that 2 is actually in white font. It looks like the 2% is invisible right here. So anyway, little things like that are things you notice before hopefully you release something to the public. I like these better. I do. And I promised you a discussion between counts and percentages. Here's a reason I like percentages. I like them because they're everywhere. And the more I use them, the more I force myself to make peace with their relative size. For example, you heard me mention before, 19% was about 1 in 5, and 11% is about 1 in 9. Those are good kind of conversions to have in the back of your mind. 5% is 1 in 20, 10% is 1 in 10, 1% is 1 in 100, and things like that. 8%, that's about 1 in 12. So I like to kind of play the game of doing mental conversions with percentages. I'll tell you what, I don't like percentages. If you just gave me this pie chart right now, I would have no idea how many students are actually in this pie chart, included in this pie chart. 10% of them clearly have 4 quizzes left to do. I get that. But I don't know what that's 10% of. Is it 10% of 100? Is it 10% of 1,000? Is it 10% of, you know, whatever, 20? I can't tell by looking at this pie chart. And that's where I like counts. If it's helpful to know the size of your sample or population, that's when I like counts. So I would say, personally, if you're going to make a pie chart, make one of these variants and not this variant here, which is Technicolor and kind of annoying. Okay, now I'm going to show you a couple pie charts I never want to see anybody make, but ones that are out there. Here's my first, and I'm sure you've seen some of these before. This is the same exact pie chart that you looked at before, but it's made quote-unquote 3-dimensionally. So these are 2-dimensional pie charts. They have a height and a width. This one here also has a depth. And you can actually mess with this in Excel by changing the X and Y and Z rotations. Now, I want you to think for a moment. I want you to hit pause and think. Why aren't these good? Think about it for a second. We'll come back. Okay. Why aren't these good? Well, here's why I don't like it. As soon as you do this to something, as soon as you create a three-dimensional object like this on a two-dimensional page, like a PowerPoint presentation slide, you create what's called a vanishing point. And I'm gonna Google one of these right now. It's a very, very popular vanishing point art. All right. So for example, let's look at one of these. That's a pretty one right there. Here's a beautiful, wow, it's actually a painting sold for $1,600. We should pitch in and buy it. No, we shouldn't. But we should use it to explain what a vanishing point is. This is a person standing on a road. It's great. This road ostensibly has parallel sides. But if you draw a three-dimensional object on a two-dimensional piece of paper, you have to have those vanish off to a point in the distance to look proper. Here's a more kind of perspective drawing of it. These lines are parallel. Those railroad track lines, these lines at the porch and the overhang, those are all parallel, but they all vanish out to a point. The same exact thing happens when you create one of these three-dimensional pie charts in Excel. You create a vanishing point. Well, the problem with that is it distorts these sizes. The point of a pie chart is to be proportional. Like if you look at these two slices right here, this 7 slice is half as big as the 14 slice. It's exactly as it should be, half as big. And this 7 and that 7 should be the same size. Hopefully that all makes sense. That 4 should be half as big as that 8, and that 3 should be half as big as that 6. Well, the problem is you come over to here, and all of a sudden, the things that are supposed to be equal, like that and that, are not. That 10% looks a lot smaller than this 10%. Hell, that 18% looks bigger than that 19%. So you can see the tricks that this plays on you. The numbers are fine, but the demonstration of it is poor, in my humble opinion. Okay, here's another one I never want to see you make, ever. This is called like a breakout chart or something like this. I forget exactly what it's called. That's how it makes me feel, though. What they've done here, and I don't know whose brilliant idea this was, is they've taken the original pie chart from back here, and they've selected some of the slices. Let's flick forward here. It looks like they've selected the slices that are 1%, 3%, 8%, and 11%. Okay, so if we go back, it's these right here, I think. I think it's 1, 3, 8, and 11. It's these 4 slices right here. That must be a 3%, not a 2%. Okay. And then they've taken those, and they've combined those into a 20, the combined total of them would be 23%, which is correct, and then they've blown that out into its own pie. There is no excuse for doing that. That makes it look like you have 2 separate groups of things. Don't ever let me catch you using these. I will be so peeved. Okay, so next slide, real quick. I gave you a little do-don't list for when you're making pie charts. And you're going to notice, you're going to hear me repeating these words quite a bit as we go through making bar charts and line graphs. Make sure when you pick your categories are meaningful and mutually exclusive. For example, for mine, my categories are numbers of students who have certain numbers of quizzes left due. Meaningful to me by keeping track of that. And mutually exclusive, meaning any one of these students back here, let me find them, I lost them, I don't know where they went. Any one of these students right here is in one of the groups and is in no other group. So if you're in the group for 0, you cannot be in this group for 3. If you're in the group for 8, you cannot be in the group for 5. Another word for mutually exclusive is disjoint. Those are fancy stat words. You don't have to worry about them. And I say make sure your graph speaks for itself. Clear fonts and sizes, crisp colors, good title. You could argue that some of my pie charts are pretty lame, and that's totally fine. We'll get into more of that later. Don't use 3D pie charts and don't use no breakout slices. I implore you, don't do that. So now what I want to do is I want to show you some pie charts I've made and some pie charts that I've found that I think are very, very fascinating. Here's one that I used to do when I taught my 244 class at COCC. One of my favorite experiments was the M&M experiment. I'd bring bags of milk chocolate M&Ms to class, and I started it in 2006. And I think the last time I did it was in probably 18. And I keep track in milk chocolate M&Ms over that time period. There are 6 colors: red, brown, yellow, green, blue, and orange. According to the Mars company who makes M&Ms, if they are made in the Hackettstown plant, you should have these percentages of colors in the bag. So a quarter of them should be orange, a quarter should be blue, and then an eighth should be these 4 colors. If they come from the Cleveland plant, these are the percentages that you should be getting in bags, which first question I always ask them is why, but I've never gotten an answer to that. This is what I've actually seen over this almost decade and a half of doing my experiment. So I've seen 12% red, 13% brown, 19% orange, and so forth and so on. I like using pie charts for this for a couple of reasons. First of all, I can color code the slices to match the candy, which I think is super fun. If you get a candy in a bag of M&Ms, it needs to be one of these 6 colors, and it can't be more than one of those 6 colors, which is fabulous, except for the one time I found one once that was white. It must have missed the painting phase. I guess they put like an enamel on them and then painted one of the 6 colors. But throwing that, of the 100,000 or so that we counted, we throw that one away. So you're either red or brown or orange or blue or green or yellow. You cannot be more than one, and you must be one of those. That's why I like pie charts in this case, more than a bar chart or something else. Okay, so these are some of the pie charts I use. I don't use them all that often. I also use them later on in probability when we look at rolling dice. More on that later. Here is one of my favorites based on raw interest, but also it's a thinker. So this is a little crazy, but maybe after I introduce it, you hit pause and look at it for a little bit. How many people are locked up in the United States? Hit pause and think about this one, and we'll come back. Now, I just think this is fabulous because it breaks down the kinds of prisons, whether they're federal, state, or local, youth. And then in each of those, it breaks those down into the types of crimes. And then of those, it breaks it down into the category of that type of crime. So in violent crimes in state prisons, you've got other: assault, robbery, rape, sexual assault, manslaughter, murder. I guess other than other, those are the main kinds right there. Another thing I love about this graphic is the fact that it says 1.3 million people are in state prisons. Another way you could say that is you could say it's 1/3 of 1% of Americans, because that's roughly what 1.3 million is. I mean, we could look at it more carefully, but if you divide that number by the total number of people in America, it's about 1/3 of 1%. But 1/3 of 1% seems tiny compared to the number 1,316,000. As a matter of fact, they even tell you up here, 2.3 million people are confined in these jails. Now, you might be looking at this also, and you might look at this and say, wait, I thought you said you didn't like those breakouts. I'm like, you're right. I don't like those breakouts when they break out with a pie chart. I love this because this gives us detail that we couldn't see in here. So this is not a pie chart breakout. This is like a sector breakout. I got no problem with this because if you try to put that text in here, you'd never be able to see it. But this way you actually get that detail that you wouldn't be able to see, like that little pink and that little dark red. You wouldn't be able to see Indian country and military prisons. You wouldn't be able to see those. This is 2018, and this is 2019. Whoops. And this is 2019. And I'm going to flip back and forth between them a little bit. There's 2018. And there's 2019. And you can see there's definitely some differences some differences. They decided to change how they dedicated the youth slice up here. It says youth 48,000 here, and I guess they didn't like the way that looked. So now they put youth 46,000 and they break it down here, and that's totally fine. On your homework, I'm going to ask you if anything jumps out at you between 2018 and 2019. And I'm curious if the same thing jumps out at you that jumped out at me. A lot of it looks the same. Even 2.3 million people, about the same number of people, 2.3 million, 2.3 million. But something definitely did jump out at me between 2018 and 2000. I'm curious if you see the same thing I do. All right, so make a note of that, and we'll on to the next